This particular curve here is the degradation curve for bearings, and we can actually measure our bearings failing. We know that we can detect the vibration signature, we can detect temperature rise, we can detect audible noise. As the bearing begins to fail, it tells us it's in trouble. We first pick up evidence of a problem at this particular P point, the potential failure point. That's the earliest point in its bearing life that we can detect some evidence of it no longer being in good condition. We do that with things like vibration analysis and ultrasonic energy detection. So we have some very high technology solutions here to find that point. If we wait longer, then our bearing degrades down to the point where we can actually touch the bearing and she's hot. We know she's close to failure. If we wait a bit longer again, we get to the point where we actually hear the noise. The bearing starts to squeal. So it comes down this degradation curve. Condition monitoring, the methodology of that is to find this P point as early as possible, to find where the trouble is becoming evident, and then before this bearing actually causes a problem is to replace the bearing. The problem starts at the F point, the functional failure point. By the time it's here, that bearing is unsuitable to remain in service. That machine is in trouble, in serious trouble. So we want to have this PF window. The sooner we can find the P, the longer the time we have to plan for the job and replace it before it becomes a breakdown. When it comes to maintenance strategies, we use this curve in a couple of ways. I can maintain my bearings at this point here, but this requires high technology, well-trained technicians, very expensive approach, but one that's very, very practical. It works well, many companies apply it. Or I can have a technique where I actually wait for the bearing to fail, and at this point here, when it becomes obvious to the operators, I can maintain the machine at this situation too. But if I maintain a machine close to the F point, then it means internally in the company, I will have to have the parts. Got to have the parts on site. Whereas here, if I find it at the P point, and this is a 2-month window, then I can order those parts in that 2 months. So this level here, this point here, and this technique here of high technology condition monitoring, I can have less spares because I've got time to buy those spares in. If I have low tech condition monitoring at this end here, where I'm using my body sensors, I'm using low cost equipment like here, then I've got to hold those parts very, very close. Or they're a phone call away and the car's here in a couple of hours. So I don't mind how you do your maintenance, but understand, depending where you are, you have to approach it in a certain way. One way is more generous, but also more costly. This way here is less time, but it means you have to carry the risk and manage that risk in a different way. The whole point being is, once the thing gets stressed, it's on its way down. Once it begins to fail, there is no way of stopping that. And at least I can reduce that stress. If I can take that stress away from my parts, then I'm having less likelihood of failure. So yeah, this curve becomes very important in our choices and certainly in the condition monitoring techniques we choose to use.